Hello, this is College Algebra's Lesson 1-2 on unit conversion. Here is example number 1. Unit conversion usually starts with your traditional scientific notation, which I'm sure many of you have done in the past. So what I'm going to do here with example number 1, as you copy it down, is I'm going to take the number 124 and turn it into scientific notation. Currently it's not in scientific notation. If you remember correctly, scientific notation usually looks like some decimal number times 10 to an exponent, to a power. So this 124, I'm going to begin by converting that into a decimal. And the question is, where do you put the decimal? Now currently it's right here at the end of the 4. That's usually where the decimal goes if you don't see one. Well, the decimal is not there in scientific notation. We want it to be here. Now, why should it be placed there, do you ask? Well, this beginning number here needs to be a number between 1 and under 10, so a little bit, so 9.9999. You want it to be just a one digit number, so the decimal place usually goes after the first number you see. So 1.24, and then I need to multiply that by a 10. Now the only other question is, well, what power? Well, 1.24 times 10 to some power, that power happens to be a 2. Why is it a 2? Well, the decimal point was here, and it was moved 2 places to the left, so the answer is 1.24 times 10 to the second power. I did clip this from online, so you can kind of see the digital version as how they worked out this problem here. As we move, the example is now converting the other way, going from a scientific notation problem into a decimal. So this problem here, 3.6 times 10 to the 12th, you're going to need to move the current decimal, which now lies here, and if you look, this number is between 1 and 10, and you need to move it, the decimal, over. How many places? Well, the exponent tells you, 12 places. Well, which way do you go? Well, 10 to the 12th is 10 times 10 times 10 times 10, 12 times. So that's a very large number, so my result should be a very large number. So the way I like to do it is I like to do it the bump method. And here's what I mean by that. It's going to go 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots, 7, 8, 9, 10, 11, 12. This bump method tells you how many zeros you need, and every bump you need, you should have a 0 in that place. So this is a lot of zeros because this is a very, very large number. So since there was one extra 6 here, actually I'm going to be adding 11 zeros. Let's make sure I did that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I did. So my final answer is going to be 3, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Commas work nicely in large numbers such as this, so you can really kind of read it to yourself and you know the value of that number. So as I move this, I'm going to try and keep it on the paper so you can see where it goes. Remember, the decimal is now at the end here. You can see how they explained that problem to you. That's example number 2. For example number 3, this is part A and part B. I'm going to have you do these two problems on your own. Pause the video as you do them and see if you can convert these the same way I did there. There is going to be a small difference, and let's see if you can figure that out. I'll give you a hint. The example 3A, which is this very first problem here, 4.2 times 10 to the negative 7, it has a negative exponent. We didn't have that in the last problem, so let's see if you can figure that out. So pause the video now, give it a try, and then I'll show you the answers in a moment. Okay, hopefully you're all done. Here are the answers with explanation. As you can see, you got point for the first one, 0.000000042. That decimal was moved 7 places to the left. Why left? Well, a negative exponent, when you have something like that, that's a really tiny number, so your result should be a really tiny number. And for the second one, which is also a really tiny number, your exponent on the 10 is also going to be a negative number, as you can see it is here. So we will be going over some more of these in class if you need help, but here's a little start for you. And then the second part of this, it goes into a little bit more story of trying to convert. So here's example 4. I've got 2 more left. What we're going to do in this problem here is we're going to attempt to take 8,975 meters and convert that into kilometers. Well, for a problem like this, you're going to need to know how many meters are in a kilometer, how many kilometers are in a meter. That can be done through charts, sometimes given to you. And if you don't know, unit conversion sometimes confuses me because there's so many unit conversions. You could always, Google it or look it up or find a device and figure it out. In this case, I know kilo in the metric system means 1,000, so I know that there's 1,000 meters in a kilometer. That's the conversion I'm going to use. So 1,000 meters equals 1 kilometer. Now, what I'm going to use is I'm going to use this conversion, 1,000 over 1. Now, the thing that sometimes I used to be fooled by is I'll always multiply. Do I multiply by 1,000 over 1 or 1 over 1,000? Some people can intuitively tell. For me, I kind of don't really mess around with it. All I do is I multiply it by a fraction, and I know that the meters here are on the top because this is a whole number, so my meters here have to be on the bottom to give me the canceling. That's the way I like to do unit conversion. So the 1,000 goes with the m, so that's what I have here, and the 1 goes with the kilometers, so that's what I have on the top. So basically, whatever 8,975 divided by 1,000 is, because 8,975 is over 1, so 8,975 times 1 is 8,975, and 1 times 1,000 is 1,000, and I just need to basically figure that out. So as you can see, this was done online, and it, of course, equals 8.975 kilometers, and you can use a calculator to figure that out, or, most of you should know, move the decimal over 3 places. And problem here, the question for example number 5 is, let's talk about football for a moment. If you have a football field that's 100 yards long and you want to know how many inches that is. Let's just pretend I didn't want to take out my cell phone and I want to kind of figure this out. It's very possible you may not know how many inches are in a yard, but you may be able to kind of link that up. So let's say you had this 100 yards and you knew that there was 3 feet in a yard. So notice how the yards is on the top here, but it's on the bottom there, so it cancels. So that's why it's 3 over 1, not 1 over 3. And now I still want to get rid of that feet issue because the question asked for inches. So how many inches in a foot? Inches in a foot. Oh, that's another one I know. There are 12 inches in 1 foot. So once you get a double conversion like this, notice how your yards cancel, your feet cancel, and then you're left with that ending answer, which is the inches problem right there, which is the question. And then you just do a little math. 100 times 3 times 12 equals 3,600, and you're left with inches. Hope this is a help for you on how to do unit conversion. Thanks for listening.